All right, so let's try that again. Sorry, my phone rang, and then it stopped the video. So, scientific notation, you would bump this over. Okay, now let's read another scenario because there's lots of different scenarios with probability. So, example 2, Shannon hits the snooze bar on her alarm clock 60% of the days. Right, I can't stand people who hit the snooze button. My roommate in college drove me insane. If she doesn't hit the snooze bar, then there's a 0.9 probability that she makes it to class on time. However, if she hits the snooze bar, there's only a 70% chance that she's going to make it to class on time. On a random chosen day, what's the probability that Shannon is late for class? Okay, now there's a lot of numbers going on in this problem. Okay, so what we want to do, a good strategy when you have this many probabilities, a good strategy is to set up a tree diagram. Okay, when we set up our tree diagram, her first decision in the morning is what? Snooze or not. The probability of her hitting the snooze button is 0.60, which means probably of her not hitting the snooze is 0.4. Well, after hitting the snooze, what are the two things that can happen? She can be late or not. If she doesn't hit the snooze bar, she could be late or not. Okay, so if she doesn't hit the snooze bar, there's a 90% chance she's going to make it to class on time, which means she's not late, so 0.90, which means this is a 0.1. She cannot hit the snooze bar and either be late or on time. She can hit the snooze bar and either be late or on time. If she hits the snooze, there's only a 70% chance she's going to make it to class on time, or she's not late. So 0.7 goes here, which means 0.3 goes here. So when you set up a tree, like each layer of branches is going to add up to the 100% that we go back to. So this is your 100%, this is your 100%, this is your 100%. Now what we do, if you're snooze and late, you can multiply. 0.6 times 0.3 should give us 0.18. Snooze and on time, or snooze and not late, would be 0.6 times 0.7, which is 0.42. The and that we talked about, these are dependent events. Snooze and not late, right, are dependent events. So here, 0.4 times 0.1 is 0.04. 0.4 times 0.9 is 0.36. These numbers, after you multiply, always should add up to 1 because it's 100% of the scenarios in this tree. So now that you're looking at that, let's go back to what the problem asked for. On a randomly chosen day, what's the probability that she's late for class? You can't just add these lates because these depend on what happened here. So it's snooze and late. Snooze and late is 18% chance. Don't hit the snooze and late is a 4% chance. So the probability, because it's snooze and late, or don't snooze and you're late. So when you add them together, your final answer is 0.22. Alrighty. So let's try. Oh, can't find my paper. Sorry. Oh, I'm sticking together. Oh my goodness gracious. All right, let's check out these. All right, because then our second objective is to calculate conditional probability. So when we calculate conditional probability, let's go back to this homeowner and high school grad problem. If I phrase the question differently from the other day, all right, and I say, if we know that a person owns a home, then what is the probability that the person is a high school grad? If we know that they own a home, then that means that we're just looking at this row. All right, if we know that they own a home, what's the probability that they're a high school grad? And that answer should come up as high school grad is 221. But what is going to be our divisor this time? Our divisor is going to come out of not the 500 total, but this 340. Okay, because we know that they own a home. So this is going to be they're a grad and they own a home because we know that they're a homeowner. If if I change the language around and I say, if we know that they're a graduate, what's the probability they own a home? That means that this time we're looking, if we know they're a graduate, we're looking at this column. So if I know that they're a grad, right, then 310 should be my denominator. What's the probability that they own a home? It's still 221 because it's going to be graduate and homeowner. But this time it's over graduate. Okay, that is the conditional probability. If we know that a person is a graduate, is the condition that we're picking just from graduates. If we know that they own a home, the condition is we're picking just from the people who own a home. We're cutting out a population of the problem, like a section of the people in the problem, to pull from a smaller pool of people. This probability formula is on your formula card. It's rearranged from the one that we saw a few minutes ago in the multiplication one. So when you're looking at it, it's the probability of A occurring given that B has already occurred. So the probability of A occurring given that B has already occurred. The big deal is whatever you have here that already occurred has to go down here in the bottom. So I would have written this as the probability they own a home given that they're a grad equals this. Whatever goes here has to be alone in the bottom. Back here, this would be the probability they're a grad given that they already own a home. Because if we know they own a home, then that has to go in the denominator. All right. How we can see this in word problems, not just in a table, because you can see them in tables, you can see them in word, you can see them all over the place. In a pizza restaurant, 95% of customers order pizza. If 65% of the customers order a pizza and a salad, find the probability that a customer orders a salad given that they already ordered a pizza. Okay, so if I know that they ordered a pizza, what's the probability that they also ordered a salad? So find the probability that they order a salad given that they already ordered a pizza. That's what I don't know. So probability that they ordered a salad given that they ordered a pizza. I'm using this as my model. Remember, this is on your formula card. That's equal to the probability of pizza and salad. This order doesn't make sense. Salad and pizza or pizza and salad. Doesn't matter here. The key is that whatever you already know happened has to go down here alone. So pizza and salad was 0.65. Probability of pizza was 0.95. When you divide those down, 0.65 divided by 0.95, 0.6842. There's your answer. Okay, so let's try, we're almost done. Let's try this guy together. All right, what I want you guys to do right now, pause the video, do this problem, try this whole page on your own, then unpause and watch me go through it. Okay, so I'll talk you through it. Computer company makes desktop. Well, you're going to read it on your own. So my first layer of branches is going to be the states. Okay, California, Texas, New York. Okay, then I'm going to have 0.4, 0.25, 0.35. From California, you can have laptop or not. You can have laptop or not. You can have laptop or not. Your probabilities should be like this. Remember, if you have questions, let me know. Ask me in class, all right? I want to explain. Once you set up your tree, you always multiply straight across, right? 0.3, 0.1, 0.175, 0.075, 0.175, 0.175. Probability that the computer is a laptop. We're going to grab the 3 laptop probabilities. So probability it's a laptop is going to be 0.3 plus 0.175 plus 0.175. When you add those together, you get 0.65. Excuse me. Now, given that we select a laptop, find the probability that it's from Texas. So if we know it's a laptop, okay, find the probability that we get something from Texas, given that we know it's a laptop. That means that down here is going to be laptop. Up here is Texas and laptop. Texas and laptop is 0.175. Divided by probably it's a laptop is this here. Keep in mind, guys, you must show this addition to get this 0.65. And then we're going to have 0.175 divided by 0.65, and we get 0.2692. Okay. So, part C, given that we select a laptop, what's the probability it's from New York? All right. So, given that we select a laptop, see how I write my given that first in the second spot? What's the probability it's from New York? So it's going to be the probability it's from New York and it's a laptop over the probability it's a laptop. Probably it's New York and laptop. New York and laptop happens to also be 0.175 divided by 0.65. Just a coincidence. So we get 0.2692. All right. So, you guys, if you want a nice challenge, because you love good challenges, try this problem 8, this Kaiser problem, Kaiser Family Foundation. Try this. We'll go over it, okay? And then we'll do another video for all our complementary events.